So I want to talk about, just to follow up and add this to your notes. So everybody should write this in your notes under the 2.2 parallel lines and transversals. I haven't taped your pages in, so they're right here. This was from last video, but I haven't taped them in yet. But what I want you guys to do is I want you guys on the next page or whatever, I want you guys to do two from these problems we did in the warm-up, which was cutting parallel lines by transversals and talk about the side lengths of them, okay? Somebody get the door, by the way. Cut transversals. Side lengths. Okay. Talk about side lengths. Okay. So. Okay. Let's say that I am given lines L, M, and N. And they're going to be cut by two transversals, not just one. Okay? So, for example, all right, so here are some parallel lines I've got. Okay, so here's three parallel lines, and then here's the transversal going through them. There's two portions of this transversal. This one and this one, okay? And that's what we end up getting. So we have here lines L, M, and N, okay? Now, what we're concerned about specifically is the distance, or the portions of the transversal that go from here to here. Okay, we're concerned about those portions of it. And let's say that I have a length on one side that is 8 here and X here. And on the other side, it's 11 and 9. Before you ask, yes, this will be slightly different than your warm-up. It's okay. I'm mainly doing this for the procedure so you can see how you're supposed to do the warm-up, okay? Now, there's something we need to take in a note here that's called a side splitter. Okay? Which means if a line intersects two sides of a triangle and is parallel to the third side sorry, not side, but third, it divides the two sides proportionally. And that's the key word here to remember about, proportionally. Okay? When we say proportionally, you need to think about fractions. Okay? When you hear this word, think fractions and ratios. Okay? Think fractions and ratios. Now, why do we need to do that? Well, that's because we need to talk about the fact that 8 is proportional to x, and 11 is proportional to 9. Okay. First thing you're going to do here then is you're going to cross multiply. You're left with 8 times 9 equals 11 times x. It becomes 72 times 11x. Divide by 11 from both sides. You get roughly 6.545 ... equals x. We can round that to 6.5 equals x. Okay. Now, one question you should also ask yourself is, can you flip these fractions around and still get the same answer? Let's find out. So hypothetical for a second. If I flip them around, I have x over 8 is equal to 9 over 11. I cross multiply. Okay, we get 11 times x equals 8 times 9. We can just stop right there because it's commutative. We can see that both of those are the same problem, just 11x is on the left instead of the right. You're going to get the same answer. If you do all that, you're going to get 6.5 equals x again. I'll be x equals 6.5, but the point is that they are the same. So it checks out. Okay. All right, so let's look at another one real quick. Okay. So let's say, again, I have a similar situation. Okay. 3 parallel lines. And I have 2 lines or transversals cutting them here and here. Again, we can finish up the lines to make a triangle. Okay, there we go. And I'm going to say that this side right here is 15. This side is 45. This side is 19. And this side is x. And I forgot to mark. Make sure you also mark your parallel lines with these little, like, chevrons or arrowheads, if you want to call them that. British call them chevrons. Okay. Make sure you do that for both. All right. So naturally, we'll set up the equation here. So 15 over 45 is equal to 19 over x. Okay. Again, cross multiply. We get 15 times x equals 19 times 45. So we get 15x equals 855. Divide by 15, and that does divide evenly, by the way. And we get x equals 57. All right, that concludes the notes for this section.